Welcome to Metropolis News Tonight. My name is Asia Woodard. On tonight's news, we will be discussing. Hold on. I'm just getting word of an extreme outbreak of acids and bases. We're getting more information on how this will affect our city. We have Kiara Huff on the scene to give us more details on the outbreak.
Thanks, Asia. You may have heard of acids and bases being used in the pharmaceutical industry in things such as drug production or ingredients in your household cleaning products. But recently, acids and bases have been causing mass chaos throughout the city of Metropolis. The problem with acids and bases is that they're both incredibly corrosive, especially at high concentrations. We have advisement from organic chemists on how to identify acids and bases and their properties. Here they are now.
There are two types of acids and bases: Bronsted-Lowry acids and Lewis acids. Bronsted-Lowry acids are defined as proton-donating species. They can be identified by the hydrogen they have that can be donated. Examples include HCl, HNO3, and H2SO4. When the acid loses its proton, it becomes its conjugate base. Bronsted-Lowry bases are defined as proton-accepting species. They do not have protons to donate. Examples include NH3, OH-, CH3O-. When the base gains a proton, it becomes its conjugate acid. OH becomes H2O. Lewis acids are considered electron pair acceptors. They can be identified as electron-deficient species, for example, electrophiles in substitution reactions. Examples include BF3 and AlBr3. Lewis bases are defined as electron pair donors. They can be identified by the electron-rich center, for example, nucleophiles in substitution reactions. Examples include NH3 and H2O. A Bronsted-Lowry acid-base reaction requires a proton transfer. The base attacks the proton of the acid, and the electrons associated with the hydrogen move to the conjugate base of the acid.
Thank you, Kiara. We also have more information on how to determine how acidic a compound is. There are two ways to evaluate the acidity of a compound: quantitatively with pKa values and qualitatively with area or ARIO. This can help you to decide which acids and bases you need to watch out for. The lower the pKa value, the stronger the acid is. Important pK values include carboxylic acids, alcohols, alkanes, alkenes, alkynes, amines, and acid halides. The stronger the acid, the weaker its conjugate base is, and the weaker the acid, the stronger the conjugate base is. Hydrochloric acid has a weak conjugate base, while methane has a strong conjugate base. Therefore, pKa values can even be used to evaluate bases. The higher the pKa value, the stronger the base generated will be. When pKa values are not available, ARIO or ARIO can be used to evaluate which compound is most acidic in comparison to the other compounds present. To use ARIO, it is best to look at the acid's conjugate base. The more stable the conjugate base is, the stronger the acid is. ARIO stands for A, atom, which atom bears the charge. The larger and more electronegative atom that bears the charge will come from a stronger acid. R, resonance. Is there any resonance that will make one conjugate base more stable than the other? I, induction. Induction comes from very electronegative atoms like the halides. These atoms pull electron density towards themselves, therefore stabilizing the conjugate base. And O, orbitals. sp hybridized electrons are closer to the nucleus than sp2 hybridized electrons, which are closer to the nucleus than sp3 hybridized electrons. Therefore, in terms of acidity, sp is greater than sp2, which is greater than sp3. We will evaluate hexane and hexanol, as well as acetic acid versus trichloroacetic acid, for example.
Solvating effects are also important to take into consideration, but are generally weaker than ARIO, as they can explain differences in acidity. Tert-butyl is less acidic than ethanol because it is more bulky and sterically hindered and cannot interact with the solvent as well as the conjugate base of ethanol.
Hopefully these tips will be helpful during this outbreak. Be safe and stay tuned for tonight's featured story about a woman who was reunited with her long-lost daughter after 14 years.